Hello ladies and gentlemen, today we're going to look at polynomial division, the synthetic form. What you're going to want to have on you, your pen, pencil, and then also notes. So, looking at division in general, what did it mean when we divided things? So basically if I divide this, remember this number went inside the box, and 12 went on the outside. Then we asked 12, how many times will 12 go into 20? Well, that's just once, right? Then we went 1 times 12, that's 12. Subtracted 8, brought down the 0. Then we asked how many times will 12 go into 80? And that would be 6 times, right? And 6 times 12 would give you 72. And then you subtracted and you got an 8. Now, probably when you started dividing, this guy was named the remainder. You didn't continue going, you just named him remainder. So sometimes you did R8, that was probably what you first did, remainder is 8, or you started to do 8 over 12, right? Because 8 divided by whatever you had left, which then you guys remembered how to simplify, or you learned how to simplify down to 2/3. So my answer would have been 16 and 2/3. Let's now go to what we're going to go for today. Our goal is going to be to divide polynomials, not numbers, but actual polynomials. Now, this would be what's known as long division, because it has a polynomial divided by a big polynomial. What we're going to do is the synthetic version of this. Basically what we're doing is an abbreviated form of long division that we can do if we're dividing by x plus or minus a number. So if our whatever we're dividing by looks like x plus 3 or x minus 5 or something in that nature. So notice I have this regular long division. We have x plus 1 divided by x squared plus 3x plus 5. Now in regular long division, what you're doing is you're dividing out the polynomial. In synthetic division, though, we're going to divide out the solution, or the 0. So this is going to be a little strange in how you're going to set it up, but once you get the setup portion, it's pretty actually easy. So what you're going to do is you're going to take whatever you're dividing by, so this x squared plus 3x plus 5, whatever you're going to divide, you're going to put only the numbers in front. So notice how I have a 1 here, a 3 here, and a 5. So what you're going to do is each column is going to be its own thing. You're going to want to write this down. Realize there's no pencil, but you should have a pencil here, okay? So make sure you write. So I'm going to list each column starting with my biggest power. So my biggest power is x squared. So I'm going to put an x squared there, then an x, and then a no x. Then I'm going to list the numbers that are common with those terms. So the 1 is with the x squared, so I'm going to put a 1 there. The 3 is with an x, so I'm going to put a 3 there, and 5 has no x, so I'm going to put it there. Now, the number outside here is going to be the solution to your the polynomial that you're going to divide out. So we're going to divide out whatever makes this equal to 0. So if I would set x plus 1 equal to 0, I would get x equals -1. Hence what I'm going to divide away. So basically you're going to divide out the solution to your problem that you're dividing by. Know it's a little confusing. Let's try a few examples of it before you start to get really lost. So let's do our first problem here. We're going to divide x squared plus 3x plus 5 by x plus 1. Basically what we were doing on the other slide here. So I'm going to set it up. We're going to have this upside down box here. Now x squared is the highest degree, or the highest term I have, or my degree is 2. So I'm going to start at the x squared. I'm going to have an x and a no x column. Just labeling. You probably won't need to label by the end of this when you're learning synthetic division. I like to, just in case, so I don't miss anything. So x squared has a 1 with it, so I'm going to put a 1 there. X has a 3 in there, and no x has a 5 there. So 1, 3, and 5. Just stealing the numbers, not the x's. Now, what are we going to put out here? It's going to be whatever x plus 1 equals 0 is equal to. So what is x going to be equal to? So I'm going to subtract 1. Now I get x is negative 1. So I'm going to put a negative 1 out there. So now, here's how you're actually going to follow your synthetic division. It's a little confusing, but I know you can do it. Your first job is going to take this 1 and you're going to drop it down. You're always going to drop whatever number it is, you're going to drop it down to here. Okay? Then what you're going to do is to get this term right here, you're going to multiply. So we're going to go 1 times whatever's out here. So 1 times negative 1, that is negative 1. So basically what I did is I multiplied those two to get that term. Okay? Then I'm going to add inside 3 plus a negative 1. That is 2. Then same thing's going to happen. I'm going to multiply 2 times negative 1, which is negative 2. Then I'm going to add these. I'm going to get 3. Okay? Now, what does this mean? What are all these numbers mean? What you just did is you divided by x plus 1. So, you originally started with an x squared. You divided away an x. So what you're basically doing is dropping the degree of your polynomial. So I started with an x squared. I'm now going to be able to write this as an x and a no x. And then this is the remainder that's left behind. So let's write it. This is going to be with ever x, that's the number in front of it. So I'm going to have a 1x left behind. This 2 has no x, so I'm just going to add 2 on. And then the 3 is going to be a remainder. So I'm going to have 3 over what we divided by, which was x plus 1. So I have divided out x plus 1 from this polynomial, and I got 1x plus 2 plus 3 all over x plus 1. Alright? It's a little difficult to make sure you learn the process, but I know you can. Let's try another example, a little bit harder of an example. So I have x to the 4th minus 10x squared plus 2x plus 3. And I'm going to divide by x minus 3. So let's set up our box here. So x to the 4th is the highest power in here, so I'm going to put x to the 4th there, and then I'm just going to go down all the way. So x to the 4th, x cubed, x squared, x, and no x. Okay? Now let's put the numbers that relate to that. Well, 1 is with x to the 4th. There's not an x cubed in this problem. Huh, that's pretty strange. So what number goes with x cubed? 0. Because there's no x cubed. So I'm going to say there is a 0 with that x cubed. Here's the reason why I label my columns. Otherwise, I would forgot that there's not an x cubed, and I would have put negative 10 here. So be careful. Make sure you watch how many columns you're writing down, okay? X squared has a negative 10 there. 2 is with x, and 3 is with no x. What's going to go out here? What am I going to divide by? Well, it's whatever x minus 3 is equal to 0, so x has to be 3. Let's do our synthetic division. So, first things first, drop that 1 like it's hot. Okay? 1 times 3, 3. 0 plus 3, 3. 3 times 3, 9. Negative 10 plus 9, negative 1. Negative 1 times 3, negative 3. 2 minus 3, negative 1. Negative 1 times 3, negative 3. And I get a big fat 0. That 0 is going to turn into a smiley face. You will understand in about a day why that 0 became a smiley face. Basically, it meant I have no remainder. That's wonderful when you don't have to remainder, because then I don't have to write that stupid fraction at the back of this. So, let's go ahead and write our new polynomial. So I started it as an x to the 4th. So I'm going to drop my power down 1. So this is now going to be an x cubed. This is going to be an x squared, an x, and a no x. Okay? So 1x cubed plus 3x squared minus 1x minus 1. Let's try one more. Now notice, this actually looks like a division problem. It looks like I'm dividing something. Nothing much different, it's just I have it written as a fraction, showing my division. So, let's go ahead and build our box. Inside the box, looks like x cubed's the front, so let's put x cubed all the way at the top. And then write my designation, x cubed, x squared, x, no x. Follow down until I hit to the no x, right? Looks like I'm going to have a 1 here, because that's with the x cubed. The negative 2 is with the x squared. The 3 is with the x. And the no x is negative 4. And then I'm going to have a 2 out here, because 2 minus 2 gives me 0, right? It's whatever's going to make this equal to 0. Now, let's follow our pattern again. Drop the 1. 1 times 2. 2. Negative 2 times, or negative 2 plus 2 is 0. 0 times 2, 0. 3 plus 0 is 3. 3 plus, or 3 times 2, excuse me, is 6. Negative 4 plus 6 is 2. So now I get to write my new polynomial after dividing. So I started with an x cubed, I divided on x, so now I'm going to be left with 1 less x than I started. I do have a remainder on this problem. Unlike last time when I got my 0 smiley face. So I'm going to have 1x squared. Notice I have 0x, so I'm just not even going to write him. I could just write him as plus 0x if I wanted. No x is just plus 3, and then I have my remainder, so 2 over what I divided by, this x minus 2. Just like at the beginning when we divided 8 over 12, because 8 was my remainder and 12 is what I divided by, right? So then I'll rewrite here so I get rid of that 0x. Divide it and write it as that. Just like that. And that's the end of this video. We'll do some practice when we get back. See you later, Savers!